Good evening, everyone. Welcome back from your extended spring break. I hope you all were able to both relax and also recover from the current situation we have. We currently found ourselves with the COVID-19 situation. I want you to know that the internship and everything else that's going on with it is still in progress and is still very much alive. I wanted to give you guys an update on the overall expectations for what we are planning to complete by the end of this term. This semester ends, for all of you who don't know, on May 2nd. So the week before that, which would be the last week of April, is considered to be our finals week. So that would be when this project is officially due and when it can be officially evaluated. So one verse I did want to share with you guys that has always touched my heart is John chapter 14, 1 through 6. It's the verse that says, let not your hearts be troubled. And it ends with a declaration where Jesus says, I am the way and the truth and the life. And I want to express that in times like this, we do have hope and we can share that hope with others. And I pray that each and every one of you would continue to do that with the professions you choose and with the lives you guys lead. And I'm excited ultimately for what you guys are going to do as teams and also for this class. So that being said, let's go ahead and jump right on in. We're going to talk about exploring the science of location analytics and what that means for you and this course for EGR400. So let's move right into expectations. So after convening with Esri and others about the kinds of expectations we could be reasonably expecting from each group in light of the situation that we are finding ourselves in, would be that each and every one of you would choose one of the 11 options you see on the right-hand side to implement into the geospatial application that you are planning to build as a class. For example, you could pick spatial data processing, geovisualization, spatial weights in PySal, exploratory data science with PySal, which is ESDA, space-time analysis. You can work with points specifically on a map using PySal. You can focus on spatial clustering, spatial regression, or the Pisag-York-Mollier models, which was the original models that Esri was most interested in implementing, but due to time constraints and the reasonable limitations I think all of us are experiencing with online courses and the demands that are placed on us currently, they're not expecting any of these bottom three items you see here to be implemented, although it is left for groups to decide if they still want to implement these. You're more than welcome to, and it would be a great project for you guys to try. And there's the CAR models, which are the conditional autoregressive models, and the SAR models, which talks about simultaneous autoregressive models. 9 through 11 are considered to be the hardest challenges out of the bunch, but you may choose 1 through 8 as other potential alternatives. And I can tell you 1 through 8 are much easier to implement starting out, and it's a good way to get your feet very warm and also to get yourself wetted with enough experience to begin developing a web application. I can tell you when I first started building out web applications, I began with not BYM models, I began with something along the lines of spatial data processing. So it's not uncommon to start with that and to begin building out an application using that. So the reason why I have this image of PySal is that you can see all the different types of areas that it's connected to and the types of things you can build using PySal. So here on the bottom right, there is a web page to help you get started. I recommend all the teams to look into this link and explore how PySal, which is a specific library built using Python, to implement all of what you see here on the far right, which is numbers 1 through 8, with the exception of 9, 10, and 11. To perform 9, 10, and 11, you would have to do a combination of R and Python and use what are called Python wrappers. And so we would take our code, wrap it in Python, and implement it in our application. So that's an option for the teams to decide what they ultimately want to choose to do. And I would expect the teams to decide on this by this week as well. That being said, let's move to next steps. So the next steps are the following. This is a rough guideline for each team to follow going forward. So number one, after you've picked the method that you want to develop, and the algorithm is fully functional, the first step is to construct a database that will read in the output and store those results into a suitable table format. PySal, for example, comes with many pre-built functional dataset structures, for example, pandas data frames that you can use with SQLite or PostgreSQL. Afterwards, you can begin drafting the UI requirements for presenting your results within your web application. This is simply a presentation, kind of like a storyboard of how you plan your web application to be fully functional within the web application itself. So this includes a discussion regarding user experience, user expectations, and what items the user expects to see when they finish their analysis using your application. In course number 3, you are intended to build the web user interface using either React, Angular, or some other JavaScript supported architectures, and launch your app with either Pyramid, Flask, or Django for recurring development. After you get through steps 1 through 3, great job. Those are usually the 3 hardest steps to get through. Then step number 4 is you begin to launch your web application using Docker. This is the deployment phase. And afterwards, whoever your Kubernetes person is, they will then go forward and configure the application to launch onto the local internet so that it becomes available to internet traffic so others all over CBU and across the world can then see what kind of work you've done with your web application. And of course, the last step is to review and reiterate for new features to incorporate into your web application. So if you do finish steps 1 through 4 using one algorithm, why not go back and implement another and then repeat the process? The bigger you can make this web application, the better, and the more useful it would be for your resume and also for Esri in general. Okay, so that being said, let's talk about team dynamics. Each team must decide who will take on the following roles and responsibilities by this week. There is documentation. These are the people who will focus on writing what the algorithm does, how the user interface works, and what the expectations are. This is great for individuals who are really good at writing and want to focus on the big picture and maintain a focus as well on what is key and what is important for the web application to do. These are individuals who really would rather write about the software rather than create or generate the software. So please pick an individual who would like to do this. This doesn't mean this person will only do documentation. If this person would like to do development and documentation, you may decide to do that as a team. But at least one or two people should be dedicated to documentation. When it comes to testing, at least 1 to 2 people, although I will extend this to possibly 3 to 4 people if it's necessary. Testing refers to the actual testing of your algorithm once it has been implemented onto a database. So once your database has been constructed, it is up to the testers to determine if the results are correct and if the results are what's expected. They're also there to test for the different UI components so that what the user does is what is expected for the application to produce as well. They essentially test everything from the back end of the application to the front end application to ensure everything is acting as appropriate. And then this brings us to one of the biggest sections, which is development. And this is at minimum 2 to 4 persons. I would not say you should go above 4 people. No more than 4 because this is a lot of work in general, specifically when we talk about all the other roles and responsibilities. I would pick 4 people at maximum to take care of development. Of course, you can include others if some individuals would like to be included in development. I do not mind that. But it's going to be difficult, for example, to transfer knowledge or to keep the ball rolling if the team is larger than 4 for some of these tasks. So I would say pick the 4 key people you feel are strongest in development and have them work consistently and be dedicated to the server, which is the database development, and the client, which is the web user interface development. The server would be first in primary, so these 4 people could work, for example, on the server side. And then once that is completed, and after the web user interface specs have been developed, then they can focus their attention on client-side web development. Now, this doesn't mean that those working on development are privileged in any way. Like I said, you can expand and have other team members jump in, but it's going to slow down the process because of how much focus and individual work these developers will need to have going forward. So I would be careful who you choose to do this because this is a very high profile position. You're going to have to work consistently to get a lot of components built in a timely fashion. Okay. Then we talk about deployment. At least assign 1 to 2 people who will be responsible for launching the web application using Docker. And whoever your Kubernetes person is, making sure that they're well suited to then take your Docker web application and to launch it onto the internet and to expose it to local traffic. And then last but not least is design, which is 1 to 2 persons. These are 2 people or 1 person who will focus on the user interface and the user experience. And this is all they will do. Whoever is doing design should not focus on anything else. They should not look at deployment. They should not look at development, testing, or documentation. They should only focus on design. Okay? So whoever is interested in doing design, please be sure you stand up in your group and make yourself known and obtain that position. I would ask that each group try to decide who is going to take on each of these different roles and then send me an email, whoever is going to do so. I would say the person who is in charge or the Scrum Master to let me know who is going to be assigned to which components and what algorithm you're deciding to implement and who is going to be doing what in this setup. Okay. And then that brings me to Scrum Expectations. That means you will plan to meet with your team members to obtain updates on each member's current progress, as well as determine the necessary components that are outstanding for your project area. I'm going to recommend, I'm not going to say you have to, but you must meet with your group at least once a week virtually if you want to be successful and to discuss what components are needing further development in your projects. I would recommend Tuesday, 5:30 to 7 o'clock for teams to meet virtually to discuss what items are left outstanding and what items need clarification and how you want to proceed further. Okay? And 2, each Thursday, and this is mandatory, the designated lead for the group, which is usually the Scrum Master, will meet with me online during 5:30 to 7 o'clock every Thursday from here until the end of the semester to discuss the current status of their project. Everyone in the group is encouraged to come, and I don't mind others from groups to come if you want to hear the discussion that we have, but only 1 member of the group is required. Okay? All right. And then I want to encourage all of you to ask questions. Please use office hours, my virtual office hours from 4:10 to 5:20 every day, Monday through Friday, using WebEx, and be sure to create a WebEx account if you haven't already, and ask questions during that time about your project, making sure that you're on task and that you're completing the project as expected. And for today, for 331, I would ask that each of your teams watch the video I have here linked below to help you begin to brainstorm how you plan to form your analysis with a spatial analysis paradigm. This video it was given by Esri. The woman who presents, her name is Lauren Bennett, and she is our principal data scientist, and she also works with all of our spatial statistical software and does a great job of demonstrating how you would begin to use an application with spatial statistics so you can help begin to have an understanding of what kind of user experience and user interface you would like to implement yourself. Okay, so that's the end of this presentation. If you have any questions, please let me know. I do expect the Scrum Masters to give me a list, like I said, here pretty soon, at least by this Thursday, regarding who is doing what in the team and also what algorithm you're deciding to implement. And of course, I plan to meet with the Scrum Masters on Thursdays to make sure this is being accomplished as well. Okay, well, if there's any other questions, please let me know, guys. I am looking forward to each group producing some great quality software. And of course, I'm looking forward to what you guys will ultimately create and how it will basically change the way Esri does business. Thank you, guys. Have a great night. Bye-bye.